Here's how a cooling tower works. Warm water from a heat source, such as commercial air conditioning or industrial equipment, is pumped to the top of the cooling tower. The warm water enters the cooling tower and is evenly dispersed over the tower fill. It then flows down the fill, which spreads the water over a larger surface area to increase evaporation and remove heat. Large fans draw air across the fill, which accelerates evaporation and further cools the water. The cooled water continues to flow down into the tower sump and back through the system to cool the heat source. As system water evaporates, only pure water is lost. All of the elements in the system water remain behind in less water volume. To make up for the water that is lost to evaporation, fresh water is introduced into the cooling tower through the makeup line. This fresh makeup water carries additional elements into the system water where they accumulate. The more water that evaporates, the greater the need for makeup water to replenish the system, and the faster the concentration of elements build. To reduce the concentration of elements in the system, a bleed-off valve opens and dumps a portion of the system water to drain as wastewater. This wastewater discharge must also be replenished by adding more fresh makeup water to the system. Because makeup water carries fewer elements than the system water, it will slowly reduce system concentration. During normal operation, evaporation, bleed-off, and makeup are balanced to maintain the proper water volume while creating a continuous open loop. This is how we build cycles of concentration. What are cycles of concentration? It is simply the measurement used to compare the level of elements in the system water to the level of elements in the makeup water. For example, if the incoming water has a concentration of 300 parts per million and the system water has a concentration of 900 parts per million, the system water is 3 times the level of the incoming water, or 3 cycles of concentration.